Welcome to Do the Math America. I am Charlene, Math Shaman. This is Lesson 7 on real numbers. We will be using A+ notes for beginning algebra, pages 9 through 12. Please use the link in the description box below this video for the PDF file of the textbook, which you may use to print out a hard copy for yourself. This textbook is no longer in print and is not available for purchase. I will be using this textbook for the next 40 lessons, so you might want to get a copy of the entire textbook. That way you can use it for reference when necessary. Real numbers are made of rational and irrational numbers. Rational numbers include fractions such as -2/3, -1/2, 1/2, 2/3, 3/4, etc. Decimals such as -1/10, -5/10, 1/10, 1 2/10, and 3 45/100. Repeating decimals such as 0.1 with a bar over it, which would be 0.111, repeating 3.54 with a bar over it, which would be 3.5454, repeating, and 3.415 with the bar over the 15, so it would repeat as 3.41515 to infinity. We will discuss these numbers in greater detail in future lessons, so don't worry too much if you don't understand these numbers right now. Continuing with our list of rational numbers are integers, which include positive integers, also called natural numbers, so like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. 0, and negative integers, -1, -2, -3, -4, -5, etc. The other category of real numbers are irrational numbers. Those are non-repeating infinite decimals, such as pi, which is 3.1415, etc., the square root of 2, which works out to be 1.4142, etc., and the square root of 3, which works out to be 1.7320, etc. We will discuss those numbers in more detail later. All real numbers, that is, rational and irrational numbers, can be graphed on a number line. And I apologize, that should be graphed as in graphed. So here is a number line with 0 as the origin. To the right of the origin are positive numbers, getting larger as you go farther away from the origin. And on the left, we have negative numbers, getting smaller as you get farther away from the origin. Each point on the number line is called the graph of the number on the line. The number is called the coordinate of the point. The coordinate of point A is -5. The graph of -5 is point A. The coordinate of point B is 6. The graph of 6 is point B. So the definition of real numbers are numbers which can be located on the number line. Rational numbers are numbers which can be written as the ratio of two integers. So 0.1 equals 1/10, 0.5 equals 5/10, which also equals 1/2. 1.2 equals 12/10, which equals 6/5, and 0.1 with the bar over it, over the 1, equals 1/9. 0.54 with the bar over the 54 equals 54/99, which equals 6/11. We will discuss these numbers in greater detail in future lessons. Every rational number can be expressed as either a terminating decimal or as a repeating decimal. Irrational numbers are numbers which cannot be written as the ratio of two integers. They are non-terminating, infinite, non-repeating decimals. Integers. They are positive integers, negative integers, and zero. Zero is an integer, neither positive nor negative. Positive integers, numbers which we use to count objects, such as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. They are also called natural numbers or counting numbers. Whole numbers, they are zero and positive integers, such as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. Prime number is a whole number other than 0 and 1, which is divisible only by 1 and itself, such as 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, etc. Composite number, a whole number other than 0 and 1, which is not a prime number, such as 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, 20, 21, 22, 24, 25, 26, etc. On a number line, the numbers to the right of the origin are positive, and the numbers to the left of the origin are negative. On a number line, the number on the right is greater than the number on the left. This sign means is greater than, such as 5 is greater than 2, 2 is greater than -1, -3 is greater than -6. And this sign means is less than. So 2 is less than 5, -1 is less than 2, -6 is less than -3. Rule of rounding is used when an exact computation is not needed for the answer of a problem. We use the rules of rounding to estimate numbers. We can round each number to the nearest 10, 100, 1,000. It depends on how accurate the answer we need. We use the symbol squiggly equal, which means approximately equal to. If the digit to the right of the digit to be rounded is 5 or more, we round up by increasing the digit to be rounded by 1 and replacing the digits to the right with zeros. If the digit to the right of the digit to be rounded is less than 5, we round down by leaving the digit to be rounded the same and replacing the digits to the right with zeros. So for this number, we want to round to the nearest 10. We look at the tens digit, which is 2, and the number to the right, which is 6. So since 6 is greater than 5, we round up. So rounded to the nearest 10, this becomes 928,430. If we round this to the nearest 100, we look at the 100 digit, which is 4, and the digit to the right would be 2. And since 2 is less than 5, we round down, which means 928,400. Rounding to the nearest 1,000, we look at the digit in the 1,000 value, which is 8, and the digit to the right, which is 4. Since 4 is less than 5, we round down, so that gives us 928,000. Now we round to the nearest 10,000. We look at the digit in the 10,000 place, which is 2, and the digit to the right, which is 8. So since 8 is greater than 5, we will round up, which gives us 930,000. So in summary, 928,426 is approximately equal to 928,430 when rounded to the nearest 10, which is approximately equal to 928,400 when rounded to the nearest 100, which is approximately equal to 928,000 when rounded to the nearest thousand, which is approximately equal to 930,000 when rounded to the nearest 10,000. Place value of numbers. Every digit that make up a number has a place value name. The first digit to the left of the decimal point are the ones. To the left of the ones are the tens. To the left of the tens are the hundreds. Next to the hundreds are the thousands. To the left of the thousands are 10,000s. Next to the 10,000s are 100,000s. Next to that is millions. To the left of the millions is 10 million. To the left of 10 million is 100 millions. And to the left of 100 millions is the place value for billions. Immediately to the right of the decimal point are the tenths. Next to the tenths are the hundredths. Next to the hundredths are the thousandths. And next to the thousandths are the 10,000ths. Hint: 0.1 is 1/10. 0.2 is 2/10. The short word name of 21, 234, 567, 809.1234 is 21,234,567,809 and 1,234 10,000ths. If you ever find yourself with the need to write a check for this amount of money, you would write it out this way: 21,234,567,809 and 1,234 10,000ths. This check might be written for some sort of cryptocurrency. To write a number in words, the comma can be omitted. To write a number in words, we must use a hyphen between 20 and 100. Never use the word "and" when we write the whole number part. To write the decimal point, we write the word "and." In order to get good at math, you have to do lots of practice problems. The practice problems for this exercise can be found on pages 11 and 12. The first set of practice problems tend to be warm-up exercises, a little easier, and the ones towards the end are harder. Please challenge yourself to do as many problems as you need to get a firm grasp of the material, and please check your answers with those in the back of the book on page 289 to make sure you did the problems correctly. I hope you found this video helpful. Thank you for joining me at Do the Math America.